By the time children are 3 years old, they already have an adult-like preference for visual fractal patterns commonly seen in nature, according to University of Oregon researchers. That discovery emerged among children who have been raised in a world of Euclidean geometry, such as houses with rooms constructed with straight lines in a simple non-repeating manner, said the study's lead author Kelly E. Robles, a doctoral student in the UO's Department of Psychology. Unlike early humans who lived outside on savannahs, modern-day humans spend the majority of their early lives inside these human-made structures, Robles said. So, since children are not heavily exposed to these natural low to moderate complexity fractal patterns, this preference must come from something earlier in development or perhaps are innate. The study published online November 25 in the Nature journal Humanities and Social Sciences Communication. In it, researchers explored how individual differences in processing styles may account for trends in fractal fluency. Previous research had suggested that a preference for fractal patterns may develop as a result of environmental and developmental factors acquired across a person's lifespan. In the UO study, researchers exposed participants, 82 adults, ages 18 to 33, and 96 children, ages 3 to 10, to images of fractal patterns, exact and statistical, ranging in complexity on computer screens. Exact fractals are highly ordered such that the same basic pattern repeats exactly at every scale and may possess spatial symmetry such as that seen in snowflakes. Statistical fractals, in contrast, repeat in a similar but not exact fashion across scale and do not possess spatial symmetry as seen in coastlines, clouds, mountains, rivers and trees. Both forms appear in art across many cultures. When viewing the fractal patterns, Robles said, subjects chose favorites between different pairs of images that differed in complexity. When looking at exact fractal patterns, selections involved different pairs of snowflake-like or tree branch-like images. For the statistical fractals, selections involved choosing between pairs of cloud-like images. Since people prefer a balance of simplicity and complexity, we were looking to confirm that people preferred low to moderate complexity in statistically repeating patterns, and that the presence of order in exact repeating patterns allowed for a tolerance of and preference for more complex pattern. Although there were some differences in the preferences of adults and children, the overall trend was similar. Exact patterns with greater complexity were more preferred, while preference for statistical patterns peaked at low moderate complexity and then decreases with additional complexity. In subsequent steps with the participants, the UO team was able to rule out the possibility that age-related perceptual strategies or biases may have driven different preferences for statistical and exact patterns. We found that people prefer the most common natural pattern, the statistical fractal patterns of low-moderate complexity, and that this preference does not stem from or vary across decades of exposure to nature or to individual differences in how we process images, Robles said. Our preferences for fractals are set before our third birthdays, suggesting that our visual system is tuned to better process these patterns that are highly prevalent in nature. The aesthetic experience of viewing nature's fractals holds huge potential benefits, ranging from stress reduction to nature provides these benefits for free, but we increasingly find ourselves surrounded by urban landscapes devoid of fractals, he said. This study shows that incorporating fractals into urban environments can begin providing benefits from a very early age. Taylor is using fractal-inspired designs, in his own research, in an effort to create implants to treat macular degeneration. He and co-author Margaret Serino, professor of psychology and director of the Integrative Perception Lab, also have published on the positive aesthetic benefits of installing fractal solar panels and window blinds. Fractal carpets, recently installed in the UO's Phil and Penny Knight campus for accelerating scientific impact, are seen in the new facility's virtual grand opening tour. Serino and Taylor also are collaborating on future applications with Ihab Eltsiadi, a professor in the UO's Department of Architecture. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.